Okay, let's unpack this. Today, we are taking a truly fundamental deep dive
into something called Graviton Pressure Theory, or GPT.
Yeah, and the mission here, it isn't just about tweaking standard physics, is it?
No, not at all. It's a complete re-examination, right from the ground up.
We've got these sources detailing GPT's core argument, and it's pretty bold.
It really is. The claim is that modern physics, well, it got a bit lost in abstract math.
And missed some key things.
Exactly, like the need to actually identify how a force works, the mechanism, and, crucially, making sure the energy balances out.
Causality.
Right, cause and effect, energy in, energy out. Seems basic.
You'd think so. But GPT argues this gets overlooked. And to prove it, it goes after, well, the big ones.
The classics, these 4 demonstrations everyone sees, the ones supposedly proving mainstream ideas.
Yeah, they call them the 4 warnings.
Okay, so what are they?
We're talking the equivalence principle, that sealed box idea.
Einstein's thought experiment.
Then the feather and bowling ball in a vacuum.
Always a cool visual. Then that thing with the comb bending water.
Oh, yeah, the static electricity trick.
And maybe the biggest puzzle. Magnetism. Permanent magnets.
Okay. And GPT says these don't confirm standard physics.
Quite the opposite. GPT argues they actually show where standard physics kind of lost the plot, where the mechanism and the energy accounting went missing.
All right, let's dig into the first one then. The bedrock of modern gravity, the equivalence principle.
Right. The idea that standing in a sealed box on Earth feels exactly the same as accelerating in a sealed box out in space.
This is absolutely central to general relativity, GR.
It is. And just quickly, GR essentially says gravity isn't a force pulling things, but it's how mass curves space-time. Objects just follow these curves.
So Einstein's idea was you're inside this box, no windows. You can't tell if you're feeling gravity pulling down or a rocket pushing up.
Correct. So let's take the 2 scenarios. First, the rocket box.
Okay, rocket box.
This one's easy, causally speaking. It's closed. You need an engine. You burn fuel. That creates thrust. Measurable energy is used, and that force, that energy, flows through the rocket structure into you. You feel it as pressure.
Makes sense. Energy in, pressure felt. Cause, effect.
Totally compliant with conservation laws. You know where the pressure comes from. You can measure the energy used.
Okay, now the tricky one. The Earth box.
So you're just standing there on Earth. You feel the same weight, the same pressure pushing up on your feet.
Feels identical to the rocket.
But according to GR, what's causing that pressure?
Well, GR says nothing, no force.
Exactly. It says there's no force. You're just following a natural path, a geodesic, through curved space-time.
And that's where GPT says, hold on a minute.
That's where it screams, pal, yeah. Because geometry, well, it's math. It's a description. It doesn't produce pressure.
It doesn't push back.
And it doesn't mediate energy. How can geometry make you feel heavy?
And this is the kicker, right? Your body has to use real energy just to stand there against this non-force.
Absolutely. Your muscles are contracting, burning calories. Stand up for a week, you'd collapse. You lift things, that's work.
Measurable work. Where does the energy come from to even counter this effect if GR says there's no actual force involved?
That's the contradiction GPT highlights. The equivalence principle only looks equivalent if you ignore the energy, ignore the cause.
So what's GPT's alternative for the Earth box?
GPT brings back the energy accounting.
Yeah.
It says you're feeling a real force. You're being actively pressed downward.
Pressed by what?
By a structured external directional pressure field, a coherent flow of, well, what they call gravitons.
Okay, need to clarify graviton here, because in the standard model, that's a hypothetical quantum particle, right?
Right, but GPT uses the term differently. It's not an isolated particle like, say, a photon. Think of it more like a constituent of a universal field, like structured fluid pressure.
So like a constant flow or pressure from outside.
Exactly. A flow that provides both the mechanism, the push, and the energy. So the sealed box feels similar, sure, but the source of the feeling is fundamentally different if you account for the energy.
Okay, that definitely reframes things. Let's move to the second warning then, the feather and the bowling ball.
The classic vacuum chamber test. Drop them both.
And they fall at the exact same rate, 9.8 meters per second squared, acceleration due to gravity.
And the standard explanation is simply that gravity acts equally on all mass. Doesn't care about shape or weight.
But again, GPT asks about the mechanism.
Right, we just said acceleration needs a force, a mechanism. What is GR's mechanism here?
Still just curved space-time, following the natural path.
Yep. No physical push or pull described, which leads to the question.
How? What physically makes these two incredibly different objects, mass, density, structure, accelerate in perfect lockstep? What's the agent driving that constant change in velocity?
Well, GPT flips the script, so they aren't being pulled from inside or just following a curve. They're being pressed downward.
By those external graviton corridors you mentioned.
Exactly. And the reason they fall at the same rate in a vacuum is simply because you remove the resistance of air. Without air, the same external pressure field pushes uniformly through their structure, regardless of what they're made of or how big they are.
Okay, but here's where you said it gets really interesting. Standard physics stops at the motion, right? Kinetic energy, half mv squared.
Right, but GPT says don't stop there. Look at what happens when they land.
Ah, the impact.
Exactly. Why does the bowling ball smash the floor or deform a pad while the feather just flutters down?
Well, standard answer is momentum, right? Mass times velocity. The bowling ball has way more mass.
True, but GPT adds another layer. It says that the force, the potential to do damage, builds up during the fall. It's related to how the object resists that continuous external pressure.
Resists the graviton flow.
Think of it like, water from a hose again. Feather doesn't block much flow.
Yeah.
Bowling ball, big obstruction. Pressure builds up behind it, sort of.
So the impact isn't just momentum stopping cold.
GPT suggests it's more complex. When the ball hits the ground, that solid resistance meets the continuous external pressure that was pushing the ball. All that organized, compressed field energy that was built up during the descent suddenly snaps back or discharges.
Like releasing compressed potential.
Kind of. Field-mediated compression being released upon impact, not just speed. GR doesn't really have a concept for this because it took force out of the equation.
That idea of a force acting without an obvious energy source, that ties into the third warning perfectly, doesn't it? The comb and the stream.
Oh, absolutely. This one feels almost like a magic trick, but it happens all the time.
You rub a plastic comb, hold it near a thin stream of water.
And the water bends towards it. Against gravity. Standard explanation.
Right.
Electrostatic attraction.
But GPT sees a paradox here, a violation.
The blatant one, according to the sources. Look at the comb. It's just sitting there.
Stationary. No batteries.
No power source. It's not heating up, not losing measurable charge or current. Yet it's exerting a continuous force on the water. Accelerating the water's mass sideways, even slightly upwards against gravity.
Yeah.
That's work being done.
Continuous work. So the question is unavoidable. Where is the energy for that work coming from?
Standard physics just says attraction.
Pretty much. It invokes the force but doesn't really account for the energy sustaining it. GPT argues that makes it magic dressed in mathematics.
I remember wondering that in school.
Yeah.
Like, okay, it attracts, but how? What's powering it?
Exactly. So GPT offers a different mechanism. No attraction.
Okay. So what is happening then?
GPT calls it a corridor collapse. When you charge the comb, it doesn't gain magical pulling power. Instead, the charge rearranges its surface field geometry.
It's local field.
Yeah, creating what they call an anisotropic corridor collapse. Basically, a very localized, narrow zone of low pressure right next to the comb.
Ah, so it's not pulling, it's creating a vacuum almost.
Sort of, yeah. A pressure differential. The surrounding ambient pressure, that background graviton field pressure, is now higher than the pressure in that little corridor next to the comb.
And the water, being fluid, gets pushed into the low pressure zone, like air rushing into a vacuum, or water through a Venturi tube. It flows down the pressure gradient.
Okay, that's a completely different picture. Is there evidence for this pressure idea over attraction?
The really telling bit, according to these sources, is this. You can use a positively charged rod or a negatively charged rod, and they both bend the water stream in the exact same direction towards the rod.
Wait, if it was attraction based on opposite charges?
The direction should reverse, shouldn't it? Positive should attract the negative parts of water molecules. Negatives should attract the positive parts, maybe differently or opposite directions.
But it doesn't. Same direction regardless of the comb's charge polarity.
Which strongly suggests it's not about polarity-based attraction. It supports the GPT idea. The charged object is just disrupting the local field coherence, creating a low-pressure gate, and the external pressure pushes the water in.
That silent, persistent force leads us right to number 4. Magnetism.
The impossible perpetual force machine sitting on your fridge.
Yeah, a little magnet holding up a note. It just sits there, doing no obvious work, not getting hot, not using fuel.
But continuously exerting a force, holding that weight against gravity. For years, decades.
How does standard physics explain that energy source? It feels like a massive violation of energy conservation.
It's a huge challenge. Mainstream physics tries to link magnetism to moving electric charges,
Yeah.
relativity.
But the fridge magnet isn't moving. The charges inside are spinning, maybe, but the magnet itself is stationary.
Exactly. So the relativistic explanation doesn't really cover the stationary permanent magnet case. And it offers no real mechanism for how that internal spin alignment reaches across empty space to grab the fridge door.
The force is real, the work against gravity is real, but the energy source seems invisible.
Or just ignored. GPT, again, reframes it. The magnet isn't creating or emitting the force energy.
It's channeling it, like the comb.
Precisely. It's seen as a precision alignment tool. The specific alignment of atomic spins inside the magnet doesn't shoot out force fields. Instead, it creates a highly coherent channel or corridor through the background graviton field.
A stable pressure pathway.
You got it. A stable, low-pressure corridor extending out from the magnet.
So things like paper clips or fridge doors aren't attracted in the pulling sense.
They are pressed into that low-pressure channel by the surrounding higher ambient pressure, just like the water stream flowing towards the comb's low-pressure zone.
The magnet isn't doing the work, it's just shaping the flow of a force that's already everywhere.
It's acting as a conduit, a shaper for this universal graviton pressure. That's the GPT view. It preserves energy conservation because the energy isn't coming from the magnet itself.
Okay, quick question then. If the magnet is just channeling an existing external force, why do magnets lose strength if you drop them or heat them up? If the external force is constant, shouldn't the channel just reform?
That's a great point. Think of the magnet's internal structure, that precise atomic alignment, as the tool. It's a highly ordered state.
Right.
Dropping it or heating it past its Curie point physically disrupts that precise internal order. You're essentially breaking the tool.
So you damage the structure that creates the coherent channel.
Exactly. The external field pressure is still there, but the magnet's ability to focus it into that specific force-exerting corridor is compromised or destroyed. The alignment is gone, so the channel collapses.
Okay, that makes sense within the model. So if we scale this pressure idea way up, what about something huge like ocean tides?
Tides are presented as a perfect large-scale example by GPT.
Standard explanation is differential gravity, right? The moon pulls slightly harder on the near side of Earth than the far side.
Yes, and that explains the timing, the bulges, pretty well. Again, the questions GPT raises are, what mediates that pull across space? Where's the energy conserved when you're moving trillions of tons of water continuously?
Mechanism and energy again. So how does GPT explain tides using pressure?
It flips the pull idea. The moon doesn't pull the water. Instead, its mass blocks or redirects the incoming cosmic graviton flow.
Like casting a shadow.
Exactly. It creates a pressure shadow, a region of lower graviton pressure on the side of Earth facing the moon.
And the oceans, being fluid,
migrate towards that area of reduced pressure. Water flows into the shadow zone, creating the tidal bulge. It's being pushed there by the higher pressure surrounding the shadow.
Okay, that covers the near side bulge. But the really tricky one is always the bulge on the far side of the Earth. How does a pressure shadow explain that?
Good question. That far side bulge isn't seen as a direct effect of the moon's shadow. Instead, it's about the Earth itself interacting with the flow. As the graviton field flows past and through Earth, the planet's mass absorbs or interacts with some of that flow,
creating another pressure differential.
Kind of. It means the side directly opposite the moon is effectively exposed to slightly more unimpeded pressure compared to the regions slightly behind the Earth relative to the flow. The Earth's bulk creates a slight pressure reduction in its own wake, so the far side experiences relatively higher pressure pushing inwards, causing the water there to bulge outwards relative to the compressed sides.
So it's a combination of the moon's shadow and the Earth's interaction with the flow.
That's the idea. Both bulges are responses to pressure differences created by the celestial bodies interacting with this universal graviton field. The oceans rise because they are pressed into regions of lower pressure, not pulled by a mysterious force.
Wow. Okay, so wrapping this up, what does this all mean? We've looked at the equivalence principle, the falling bodies, the comb, the magnet, and now tides.
And in every case, GPT reframes them. They aren't proofs of abstract geometry or action at a distance attraction.
They become evidence? Testimonies, maybe? Hidden in plain sight?
Testimonies to a universe that operates on structured pressure and flow, according to GPT. It's a callback to what they term causal physics.
Meaning energy has to come from somewhere specific.
Cause must precede effect.
And motion needs a mechanism, a push, not just mathematical permission.
It's presented as a restoration of mechanism and tangible cause and effect. These demonstrations weren't just neat tricks. They were warnings about a missing layer in our understanding.
A layer of physical reality based on pressure.
And if you really take that idea seriously, that maybe all motion, all forces we see are ultimately down to external pressure interacting with resistance.
And that the energy for all this comes from some vast, omnipresent, structured field.
It really makes you wonder, doesn't it? What else could be explained this way?
Like what?
Well, think about phenomena we currently explain with very complex math, maybe without a clear mechanical picture. Aerodynamic lift, maybe. The fundamental process of combustion, even how stars and galaxies move. Could there be simpler, mechanical, pressure-based explanations hidden underneath the abstractions?
So the universe might be less about elegant equations and more about, well, physical structure and mechanics.
That's the provocative thought GPT leaves us with.
Yeah.
Maybe it's far more structural, more mechanical than we've allowed ourselves to imagine. Something for you, the listener, to mull over.